Good morning and welcome to yet another Micrographics webinar. My name is Carl van Rooyen, application engineer at Micrographics. Today's webinar is going to be on Fusion 360 extensions, and we're going to show you how to expand your tool sets. There will be a Q&A session at the end of the presentation, but if you do have any questions that come to mind, you are more than welcome to put them into the chat section. The chat is open to all participants, and I will keep an eye on that and either answer your question as I see it coming up, or I will answer it towards the end of the webinar when we do our Q&A session. So as I mentioned, today we're looking at the Fusion 360 extensions, where you're able to take your standard Fusion 360 and expand your tools within Fusion. So on today's agenda, we're going to have a quick introduction of what the extensions, or a quick introduction of what we'll cover, the short explanation of what the manufacturing extensions actually are, and we'll then go through and explain specifically or generative design, what the unlimited access means. We actually do have a webinar tomorrow as well, which will be specifically about generative design. That would be the 17th of July. Then we'll go into the manufacturing extensions where it comes to CAM and machining and also additive. We'll have a couple of demos with that. We'll then close with a summary and Q&A. Okay, so introduction. Basically, Fusion 360 already comes with a very good base of features within its manufacturing environment. And when I talk about the manufacturing environment inside of Fusion, I'm referring to the CAM environment where you can do your laser cutting toolpaths, your machining, whether it's 2D, 2-axis, 2.5-axis, 3-axis, all the way up to 5-axis simultaneous. You can also do additive. That is what would be termed the manufacturing environment inside of Fusion 360. And for some users, that good base set of features is good enough. But you get users that need more. It's not enough for their specific needs, or they have projects where their needs are, where they need more control, they need more features. So would these users who need more have to go and buy other software packages? Would they purchase more software just to be able to do what they need? But then if they do that, they would then need to have to deal with extra licensing, maybe a new supplier for the software, and that becomes a bit of a pain to the user. So what Autodesk have done is they've taken Fusion 360 and they allow you to expand the features. So no, you don't need to go and buy extra software. What you can do is expand the features directly inside of Fusion 360 by subscribing to the manufacturing extensions. So this can be done on an ad hoc basis, basically on demand from within the software, and when that purchase of the extensions will then be valid for a period of 30 days. So as a project arises and you realize you need those extra features, you can unlock those features on demand for that project and have them valid or have them enabled for 30 days. So this on-demand functionality is perfect for this feature, or for those users who don't need these features all the time. They only need it for 1 or 2 projects during the year. Alternatively, when you subscribe to your Fusion package, you can subscribe to a package that includes a year's access to the manufacturing extensions. So you can choose that, I want to apply to this yearly so that I have access to these extensions all year round. So this removes that need to resubscribe every 30 days. So when you subscribe to Fusion 360, you can choose a package that actually includes the manufacturing extensions at an extra cost for the year. So what are these manufacturing extensions? What are the ones that you can purchase? So currently there are two different options that you can subscribe to, and it will depend greatly on your workflow and the features that you use inside of Fusion 360. If you're a designer who uses generative design on a continuous basis, then you will most likely want generative design, the unlimited extension. So this is essentially a year subscription to the software or to generative design, and it gives you unlimited access. There's no need to pay for any specifics, and we'll go through that in one of the following slides. Then if you need more machining or 3D printing capabilities, then the manufacturing extension is for you. So this extension unlocks more advanced features typically found in PowerMill or FeatureCAM. Those are other Autodesk CAM products. And these include additive manufacturing for metal powder bed fusion machines. So you can expand from doing 3D printing with plastics to actual laser sintering or metal powder bed fusion. Strategies like steep and shallow with 5-axis collision avoidance, hole recognition, probe geometry, surface inspection strategies, rotary strategies, and also toolpath trimming. So for the bulk of this webinar, we'll be taking a deeper look at the manufacturer side, the manufacturer features. Like I mentioned, there is a generative design webinar to follow tomorrow. So if we have a quick overview of that generative design unlimited access, this gives you unlimited access to all generative design functions for a year. So this means that you do not need to spend 25 credits to generate your outcomes for a study. And once you get your outcomes, you don't need to spend that further 100 credits to create the model of your desired outcome. So instead of paying per use, you pay upfront for the year. And as I mentioned, there's that webinar tomorrow, 17th July, where Fusion 360's generative design will be covered. So moving on to the manufacturing side, which is the focus of today's webinar, we will start off with looking at the additive manufacturing extension. So once you unlock your extensions within the software, you would have access to, or your additive manufacturing portion of the software will be expanded to include printing with metals, those powder bed fusion machines. And this is typically a machine where you've got a powdered metal and the machine itself will use a laser to melt that metal down to create a component. And so in your machine type setups for your additive manufacturing, you would have your fused filament fabrication machines, which is what most people think of when they think of 3D printing, a big spool of PLA. But you will also have machines that are now showing for the powder bed fusion. Inside of the machine setup, you'd also be able to adjust machine settings, things like your layer thickness, your recoating times, laser strength. You have whole settings for those specific machines. And also within the environment, you'll be able to generate native build files with laser parameters built in. And those build files are then able to load up to your machine. And you can also export a 3MF file. Now, 3MF file is a 3D printing, more specific 3D printing file format. A lot of people use the STL or mesh. 3MF is built specifically for 3D printing. So if we have a quick look at this inside of Fusion, I'm actually going to start with just showing you where you would access your extensions, and then we will have a short look at the additive environment. So in your Fusion 360 session, on the top right-hand side, you have a couple of options for accessing your account, help, any job statuses, and then there is that little spanner which brings up your extensions. And now if we have a look under the extensions, there is the Generative Design Unlimited Access, and that gives you the unlimited solves and unlimited outcome designs, and your purchase options here are purchase accessing or using a credit card or directly through your reseller for that. Then you have the manufacturing extensions. My purchase options are not shown because I have already accessed this purchase for the next 30 days. But you would have a similar drop down, and you would have options for, if I remember correctly, it's 30 days, a single day, or a 7-day trial if you haven't already unlocked the trial. And for manufacturing extensions, the extensions are listed on what you unlock. Now, one thing to understand here is that you are unlocking all of these. You cannot pick and choose between what you want to unlock. So there's a set price and it unlocks all of these features. So once again, we can see the list of features and a short description of each one of those. Once you have selected your purchase option, you can then purchase, and this uses Autodesk Cloud credits. So you would need to purchase credits for your account, and that can be done through your reseller. And once you have those credits, you can then use them to unlock the extension. Once the extensions are unlocked, you can then access them through Autodesk or through Fusion 360's manufacturing environment. So we can see currently I have the manufacturing environment active. And if I go to additive, I can then have a look at picking up those extensions. So in the setup, if I go to machine setup here and I select the machine, there are now options for metal powder bed fusion. So if I go into the Fusion 360 library, we can then have a look and filter by additive and pick out the different additive machines. So the extension unlocks more machines that you can then choose from. So there's a generic metal powder bed fusion. That's actually the one that I have currently active for this model. So if I go here to setup one and I activate it, we can see that I've got that generic machine active. Now with that machine, you're able to go to print settings and select your print settings. And within print settings, there are a couple of essentially resolution options available on this generic one. And if you need, you can then go into one of those settings and view the technology. So the SLM is that single layer or that laser melt, the layer height, and any other information regarding that actual process. Within the setup as well, you can choose your operation types. In this case, it's obviously additive. The arrangement can be applied. You can do an automatic arrangement of components within the machine, and you can then select the models that you want to, or the bodies you want to print. Within that environment, there are various options for positioning and moving the components, but more specifically, we want to look at the print settings selection. That takes us back here, but we can then also go into the print settings dialog box and adjust the print settings for that for that operation that we chose. So in this case, I've chosen the 100 micron, and I can go in here and add descriptions, comments, the spot size, build rate, recoating time, so we can have a look at those, essentially those build strategies. So for each build strategy, you have your print settings, and then also your build strategies. You're able to go in and adjust settings for that specific build strategy, and that's essentially how the laser will pass over the powder and build up the part. So there's things like your hatch density, your hatch border distance, and this essentially is creating or adjusting the pattern that the laser follows while it's melting the material. And you can also set up the recoating time in milliseconds as well. So you've got access to those print settings. Once you have done that, you can generate your supports, or let's just have a look here. My supports have disappeared, but you can generate your support types, and there are the export as 3MF options. Alternatively, you can post-process this out as the other file format, the native build file format. Okay, so just a quick overview of the additive manufacturing. A lot of this is standard for your filament type as well, but we can go into these print settings and change out the information specific for the laser machines. Okay, so moving on to the CAM options. When you unlock those extensions, you unlock extra CAM strategies. And the first one we're going to look at is the steep and shallow strategy. And what this, or should I say, start by saying, typically, as a programmer, you would look at the component and you would decide what strategy to use for steep walls, and you would apply your strategy to those steep walls, possibly as a first operation on the part. And then you would look at the shallow areas and choose a strategy that would machine the shallow areas. So potentially you could have 3 or 4 different operations for different areas of the model. Now, what steep and shallow strategy does is it will scan the part and apply the appropriate milling strategy to both steep and shallow areas. So there's no need for you to go and manually choose this. And these areas, the steep and shallow areas, are controlled by the angle of the surface, and that can be adjusted to your preference. The contour passes are used on steep areas. So those steep areas, if we look at the image on the right, there is a contour pass which will do a contour around the component and then step down and do the next contour around the component. And then shallow areas are cleared out or finished off either with a parallel or a scallop strategy. So you can actually choose between the scallop or parallel strategy. If you go with scallop finishing, that strategy has extra options allowing for smoothing of the scallop itself and also removal of cusps. So the animation on the right here shows the result of that steep and shallow toolpath. We can see that when it's showing number 1 in the red circle, that's the steep, number 2 is the shallow, and 3 is the combination of the two. You can also specify the overlap distance between the steep and shallow options there. Then with steep and shallow, there is, or should I say, within the steep and shallow toolpath, you can also enable 5-axis machining by adjusting the orientation of the tool axis. So this can be done by setting the lead or lag and lean angles. So you can set the angle that the tool tip is essentially in contact with the component that is being machined. And within these settings, you can also enable collision avoidance for the tool holder. And this allows the tool to react and move to avoid, this actually removes tool segments that would cause the tool paths that would cause the tool holder to crash. And you can also set the tool axis limits, so the leaning over of the tool, the tilting of the tool. can be set to limit the engagement angle with the material so that your tool does not lean over too far and you start machining with the side of the tool on the part. So we'll go over to a demo, having a look at the steep and shallow tool paths. So we have a nice model here from Autodesk. It is looks like a portion of a race car. We've got the cockpit here where the driver would sit. And I'd like to show you the standard scalloping procedure that is within Fusion without the extensions. And if we have a look at that toolpath, just get this view there nicely. If we have a look at that toolpath, the way that the toolpath is calculated leaves us with these steps within the toolpath. And where the scallop turns, we end up with sharp points. And this does not give you the best surface finish. It'll give you a good surface finish, but not the best. One of the issues with this is the change in direction on those steps, as well as the extended distance from apex to apex on the turns. And that extended distance will leave a much larger cusp between the cuts. Now, the scallop toolpath that is used with steep and shallow is a much smoother toolpath. It actually uses a different programming kernel to calculate that toolpath. So we can see the difference if I overlay the two, that is the standard scallop and then the scallop from the steep and shallow toolpaths. And we can see that that is a much smoother toolpath. It will result in a better surface finish. And one thing you'll notice as well is at those apexes where the tool turns, it's a much smoother turn. And there is a toolpath that actually flows through each of those apex points. So what the toolpath is doing here is this one has enabled a function that actually removes the scallops between that extended portion of the toolpath. So it'll come in there and it'll clear out all of those scallops. So giving you a much better surface finish. So we can see here on the entire mold how what the toolpath looks like. And if I go into the second demo toolpath that we have here, this has got the scallop and also, should I say, the steep and shallow portions of the toolpath in there. So we can see the entire mold base is covered with that toolpath. And once again, if I zoom in on that toolpath, we can see at each of these, go to a section where it's a little more obvious. At each of these apexes where it turns, there is that toolpath flowing through those apexes to remove those cusps. And we also have overlap between the toolpaths. We go over here. We can see overlap between the parallel, or this steep and shallow toolpaths across the center of the screen here. You'll also see that in this case, the shallow areas are being cleaned up with a scallop toolpath as well on the outsides. And the last toolpath we'll look at here is where the shallow areas are being cleaned up with a parallel toolpath. So that parallel toolpath has less changes in direction on the model. So I'll just pause it there for a second. There's less change in direction on the actual surface. However, we do see that there are a lot more retracts path. So that mess of yellow retract lines with that toolpath. So your machine is retracting a lot more. However, it's not changing direction as often on the surface. Whereas if we go back to that previous one with the scallop is a more continuous toolpath with less retracts, but it does change direction more often, especially if we look at this portion here. It is changing direction more often on the tool. So if I go in here and access this toolpath, we'll be able to see the passes options. We can set the threshold angle, the overlap distance between the pass. So that threshold angle is where it changes from steep to shallow, and the overlap distance is the overlap between steep and shallow. Steep passes can be set to continuous. So currently it steps down for each pass, where continuous will use more of a spiral strategy on the way down. And then shallow passes, you have the scallop or parallel options. The smooth offsets and remove cusps at junction, those two options are the options that enable the smoothing of that, should I say, the smoothing of the turns and that toolpath that cuts across and cuts off all the cusps. So that is a quick overlook at the steep and shallow for machining or for finish machining on your surfaces. And we will then move on to the next toolpath. The next thing was the collision avoidance, which if we stay here with the steep and shallow, we can go to the tool axis, and there are options here for tool axis to be able to set the primary mode for the axis. So it would be, let's say, vertical axis, or you set it to lead and lean. You have your various options here with the allowance of collision avoidance and how your tool will avoid collisions. You can also set the tool axis limits as mentioned. So within that steep and shallow, there are the tool axis options. Okay, the next strategy is hole recognition. Now, with hole recognition, it is used to automatically find holes in your part and select the appropriate drill or cutting tool for each hole. So when you first activate the command, it's initially set to limit the selection to holes that match your Z-axis or your setup work plane. But this can be disabled, and holes on other axes are found, and 3+2 positioning is then used to drill those. So if your machine has 5 axes, this will work well for drilling holes on all sides of your component. Furthermore, you can actually limit the hole selection by its angle relative to your initial Z-axis setup. Once the holes are found, you're able to then select an appropriate drill cycle for each hole set, and you can also ignore specific hole sets. So I'll cover these in a demo. So if we look at that component here inside of Inventor, if I had to go and manually do each of these hole setups, this would take me quite a while to go through and set up each of these holes manually. Now, the hole recognition wizard allows you to select it, and it will scan the model and find all the appropriate holes. Currently, it only found 2, a 0.15, and this is an American demo, so we're in inches, a 0.15 inch set of holes at the top here. There's 4, and a 1.5 inch hole in the center. If we go to the options, you're able to deselect the limit to setup plane option. That will then allow it to scan the rest of the model for holes. You can also choose to find by angle. So in this case, my holes are only at 0 and 90 degrees. So if I had any holes drilled in here at 45, I could limit it to an angle, which would then filter my selection. We can go find by diameter. So what I'm going to say here is find by diameter with a maximum diameter of 1 inch. So we should see that that hole at the top there is no longer selected. If we go back to hole groups, we now have all of the hole groups displayed. And we see here holes recognized, 41. You then go through that list and choose the appropriate action for each of those. So the simple holes at the top here, we can just do a simple drill, or we could choose a more appropriate option. Maybe we want to spot drill and then drill the hole to make sure that the drill bit doesn't walk. And so you can go through that list, and you're essentially choosing your options. If that hole is countersunk, if we have a look here, that has a small chamfer on it, you can then choose, and it would find that, and you can select the appropriate options for this. On the right-hand side, if we expand out, that actually gives us a preview of the hole as well. You can use that preview rather than trying to find it in the model, like I am here trying to rotate around and find where it is. Just use that preview and you can choose the appropriate action. You would go through your list, select all the actions, and then once that is done, you hit OK, and it will generate the list of operations for all those holes. So here on the left-hand side, we can see all the various operations that will be carried out. And this would take you, maybe 5 to 10 minutes at max for a part like this, if not quicker. So that saves a lot of time recognizing all those holes. So that is the hole recognition wizard that you unlock. And moving on, we will look at probe geometry. So with probe geometry, this allows you, if your machine is capable of it, it allows you to probe the part position. So I'll say if the machine is capable of it, a lot of your modern machines are able to probe and feed back its position to a report and output a report. In the case of this, we can set up your probe geometry. The top image there is probing the outside faces of the component, and it's then finding the part position. And this can then check to see if your part is in position where it expects to find it on the machine, or if that part is out of position. And we'll have a look at the options in a short demo on what you can do once the position has been probed. Alternatively, you can check for machining accuracy. So on the bottom right-hand side, that image there is checking the outside diameter of that boss, and it will check the dimensions and check the accuracy to see if you're within or out of tolerance. Alternatively, it can also be used to feed back tool wear information to your machine. So each part can actually be checked, and as the tool wears down, that information can be fed back to the program, and the program, or should I say your tool wear on the machine, updated to account for that when the machine is cutting. So we can see that last point there, feed changes or errors back to the machine, and the machine will give you feedback. Once again, these are machine specific, so you need to check that your machine is capable of these processes, and your post processor may need to be modified for this. Now, in the same lines as probing or probing to check position or to check for tool wear, the surface inspection strategy is also one that is available through the extensions. And once again, machine specific, you need to check that your machine can do this. But the surface inspection strategy allows you to probe multiple points on a model. So the image on the right here shows a very simple 3 positions that are being probed on the model. And essentially that's checking the height of each or the depth of each of those pockets. Now, when you set up your probe for multiple points, you would set up the position to probe, and you would also then set up the tolerance that you expect in that area, or the tolerance that you need in that area. So you set your upper and lower tolerances. You can also set your approach and over travel distances for your probe. So the approach distance is where it will reduce its feed rate and travel towards the part. And then the over travel is used when the probe is not activated. It will over travel by a set amount, trying to find where the part is. And if it runs out of over travel, let's say 10 millimeters, and it doesn't touch the part, it will return a error into the log for that position. It will say that measurement was not taken. So this can be done, or this allows you to do in-process quality control. So once the part has been machined, the probing process can be run on the machine. There's no need to take the part out the machine, take it off to a metrology department, have to set it up on another machine, redo setup, and then probe on that machine. Once the probing is done, that file that is generated by the machine can then be imported back into Fusion 360 and the results viewed on the model. We can see there on the right-hand side that bottom image has 3 dots. Each dot represents the probe point, and the color represents if it's within spec, above spec, or below spec. So the colors there indicate the quick indication of the result of that probed point. Now, the results can also be imported into a program called Power Inspect. This is a standalone inspection program that Autodesk provide, and that can be used for more advanced processing of the results and more advanced reporting on those results. So this is something that a metrology department would be using to inspect the physical component and compare the results back to the actual CAD data that is supplied. So we'll move on to a demo for the probe geometry. So in this part here, we have a component set up on a machine, and there are various processes or operations on this part. There's some facing, some outside roughing, adaptive clearing, top roughing, there's some pocket roughing, facing, contouring, and right at the end, to double check the accuracy of that bore in the part, there is a probe geometry function. Now that probe geometry, you'll see that in the manufacturing tabs, there is a probing tab, and there are various options here for probing. So we have the ability to probe for the WCS. That is a standard function that would essentially probe and set your coordinate system for the part. Then the probe geometry creates a cycle which would then measure the final product. So if I activate that probe geometry command here, or operation, we will see that there is a probe selected as the tool. There is a lead-in feed rate for that. And the geometry that is selected is part of the model. It's a face here on the inside of the model where the bearing may be pressed in. And the probe type is set to find a specific type of value. So in this case, it's checking the X and Y dimensions of that circular hole. There is an option here to select same diameter. So if you have that same bore in multiple places on the part, that would actually probe all of them then. Various options to order by depth to basically set the probing order. And here we see the approach and over travel values that I spoke about. So that approach will have that feed rate, the reduced feed rate, so that you don't break the stylus on your probe, and the over travel rate. And yeah, if it travels through that over travel and doesn't pick up a component, it returns an invalid measurement. And right at the bottom, we can see the position and the size. So we can report back on tolerances for the actual X and Y position of that hole and the size of that hole. And we set the tolerances for those. The feedback loop that will go back to the machine, part of the post-processing, we have a couple of options here. So this is the feedback that you get from the probe. You have an option to enable the out of position action. So if it probes for that hole and that hole is outside of the required spec, it can send a stop with message signal to the machine or to the controller, and the controller will then stop with the message to say that it is out of position. Then There is the wrong size option as well. So this will go down to the size tolerance. Once you probe that and it picks up maybe the size is incorrect or outside of that spec, it will then stop with the message. Updating of toolware. This will allow you to update the toolware for the tool used in a specific operation. So we'll see here the operation is 2D contour with tool number 134. And so that would be the contour that is used to machine the inside of that ball. So as the process goes on and more parts are machined, that tool is wearing down, and it's adjusting the tool wear for that tool that does that final pass in the ball. There are options for minimum deviation that will be allowed. So if your tool wear is outside of that deviation, then it will not update. And there is also an error correction. So this is by what percentage of the tool wear do you want to correct the tool wear option. And then print results will print the results file to the controller. And if you're running series production, you're running multiple components, let's say production run of 50, you can increment component. So in that print of the result, it will increment the component number so you can keep track of how either the tool is wearing or which components, should I say, how the tolerance changed as the components series increased. So this is a nice option for quality tracking. Now the surface inspection, once again, we're back to this part here. This one has two surface inspection options. There's a semi-finish inspection, and then there's a finishing inspection for the same points. Now, if we look at that semi-finish inspection, we can see that we have the probe selected. There are different feed rates for the probe, and the points that are selected in this case have been manually selected on the geometry. So we can see I can actually go here and add another point. I can click on the object and add another point. And that approach is always normal to the surface. So you'll see as the surfaces change, that approach angle stays normal to the surface. You can set if there are any expected surface offsets, you're able to set that on. So you may know that you have already left 0.5 millimeter or 0.2 millimeters for your finishing pass. You can add that surface offset on and then add your deviation or your tolerance. And once again, this will probe and feed that information back, or generate a report, should I say. There is a height section as well, and basically this is just setting your probe safe height. So this one is quite a simple strategy. You pick your points where you want it to probe and you set your information. And we'll see here there's a finish inspection option as well. I'll double click on that. It's much of the same setup here as well. So this will generate two reports, and those reports are then output as text files. Now, if you go to the probing tab, we said there is the inspect surface option. So with probe geometry, there's inspect surface. There is also an option to align part. This is actually something that I haven't mentioned, but that align part would allow the machine to probe the part once it's mounted in the machine, and it will compare your program setup to how the part is set up in the machine and adjust for any variation. You may not have the part perfectly level in the vise. It will pick this up and it will then adjust the program to compensate for that. Now, from a surface inspection strategy here, you can import your inspection results, and that will then overlay those dots on the model. Now, unfortunately, I don't have any search results there, but I do have an image of another search here. And we can see there are the points that are probed. And once that import is brought back in, once that report is brought back in, those points are positioned on the model, and you can then view that inspection results, and it shows you the deviation and error for each of those points. Okay, Rotary Strategy. I'm going to move on to the Rotary Strategy option, and this strategy allows you to do fourth axis milling for non-cylindrical shapes. So out of the box, Fusion can do fourth axis machining, but it's limited to cylindrical objects. So we can see on the right hand side that looks like a spiraled star. That shape would require the fourth axis strategy or the rotary milling. And when you do your rotary milling, there are 3 options on how to machine that component. You get an option for machining it using a spiral or line or circular strategy. The one shown on the right hand side here looks like a spiral strategy. The tool starts on the one end and it just continues to spiral around to the opposite end of the part. A line strategy would actually machine down the axis of the part, and a circular strategy is similar to spiral. However, it does a full circle, 360 degrees, and then steps over. So you will have a retract and so a lead in and a lead out. You'll have links between each step. With this, you can also limit the front and back references. So limit how much of the portion of that part is being machined using the strategy. And you can also limit radially with an angle. So you can limit a specific portion to be machined. So the rotary strategy I'll cover in a short demo as well as the next one, which is toolpath trimming. Now with your toolpath trimming, this allows you to select an existing toolpath and delete and have it automatically repair that section of the toolpath. So this is done by viewing the toolpath and then specifying a containment boundary or containing boundary. And you can choose to keep the toolpath within that boundary or outside of that boundary. And the image on the right-hand side here shows a toolpath where the tool actually goes over a ridge in a component and machines down the opposite side of the ridge. And that extra bit of machining is not required. That portion of the mold may have been machined already, so you'd want to trim that off. So to show these in a demo format, we have a rotary component here where we need to machine that star shape around this hub. And we can see the various toolpath options here. So this one here is a spiral toolpath. We see that we have a lead in. It will spiral around the component with a set step over, and then it will lead out on the other side. The second rotary we have here is a line rotary, and you can see that it runs from one selected face to another, and it runs along the axis of the component and machines at a set step over. And that step over is an angular step over. So if I edit that rotary and go to the geometry, we have the rotary axis selected by that central hub. The front mode face, or the front face, is the star that is selected here on the front. And then the back face is that base face, and the machining happens between those two faces. You can also add an offset. So we can see from that face, there's an offset so that the machining happens purely on the straight section and not where the fillet is. You can also set, as I said, angular limits. So you can choose a point on the model, and you can say that you want to offset or machine between that point and another specified point. And so it will only machine between those 2 points. If I hit OK, it will update that toolpath, and it will then show the machining only between those 2 points. So you can use that angular option to limit the machining. There's another rotary, and there's actually another example with the angle limits set. So that would be your rotary machining. Various options here. If we just edit this one, had a look at angular limits. But if we look at passes, we have options here for changing the style to spiral, line, or circular. There is also the step over on the component as well. So this A axis will rotate 1 degree and then the next line will be machined. So the smaller that angle, the better the surface finish, but obviously the longer it's going to take. So this will do 360 passes around the component. Then the toolpath trimming, as mentioned, you would take a toolpath and you'd see that on this toolpath there are some areas where you get unexpected results, and that is going to not leave a good surface finish on the part, and you may want to remove that. So this tool is actually very impressive. It allows you to select the toolpath, choose the modify option up on the milling tab, and you then draw out your boundary points. So I'm going to go ahead here and pick a couple of points to specify the boundary. And what this does is it uses the direction in which you're looking at the part to trim through and create that cutting operation that cuts off all the toolpath. So if I hit accept here and I rotate the view, you'll see that there is a box that is generated. And that was generated from my initial view when I created that boundary. And that is then going to trim away those portions of that toolpath. So here I can choose to keep inside or outside boundary. Clearly, I want to remove what's inside of that, so I keep what's on the outside. Hit OK, and it will then update that toolpath. And instead of calculating or recalculating that entire toolpath, it only needs to calculate and fix the affected section. We can see that piece is trimmed off. I'll do that process again. Let's go into a top view for this one. Select the toolpath, select modify. And in the case here, I'm going to go ahead and draw that box around. If you accidentally picked a point that you don't want to have, you can use the delete point mode option and select the point, and it removes that point. You've got options for deleting and cancel that selection. If you rotate your view, you can also return back to that view because this is based on the view that you are using. Once again, hit OK, and it recalculates that toolpath with that trimmed portion. And so you can quite quickly and easily go through your model, and I see here's another one at the bottom, and trim away that geometry. So let's just do a very quick one here, and this will be the last one that I'll do. And the nice thing about this is, like I said, you don't have to wait for the entire toolpath to recalculate, because a toolpath like this could take some time to calculate. And I'll leave it at that for now. So that is the toolpath trimming and the rotary axis. So in summary, the Fusion 360 extensions, the manufacturing extensions, allow you to expand the capabilities of your manufacturing environment. These capabilities allow you to improve productivity with quicker calculation times on your programming, quicker programming times because of recognition of, let's say, things like your hole features. It reduces that, or improves the productivity, reduces your programming time. It can improve surface finish. We looked at that steep and shallow and how that has options to improve the surface finish. Using the inspection strategies, you can ensure your part accuracy, and it makes Fusion more flexible to your needs. As you get special projects in, you can unlock those extensions and use them as needed. So to close off, thank you for spending the hour with us on the webinar. If you have any questions, you are more than welcome to type them out in the chat, and I will then answer them as best as I can. Okay, this webinar has been recorded. It will also be uploaded to our YouTube page, the Micrographics YouTube page. So if you want to view any of this information again and refresh at a later stage, you can go and find that on our YouTube page. And also, once again, tomorrow, 17th July, we have a generative design webinar that is going to be held. I don't see any questions coming through yet. I'm just going to give another minute or two before I end the webinar. Okay, don't see any questions coming through. Thank you for attending the webinar. This was proudly brought to you by Micrographics. We have 4 offices in South Africa. We've got Johannesburg, Cape Town, Port Elizabeth, and Durban. And you're more than welcome to email any of those. We email the closest office for any more information. Like I said, my name is Colin Roy, and I'm also an application engineer at the Port Elizabeth branch. And we'll go back to the first slide and you can get my email address off that first slide. Yeah, thank you for attending the webinar.